Alright, adding and subtracting rational expressions. The first thing we're going to do here is review how we add fractions. Okay, and everybody remembers you have to have a common denominator. And in this case, our common denominator would be 12. And most people just kind of intuitively know that. Now they know that 12 is a multiple of 6 and 12 is a multiple of 12. But let me show you exactly why this works. What I'm going to do is take and factor the denominators. So 6 factors is 2 times 3. And 12, break it all the way down, is 2 times 2. That gives us 4 times 3. If we look at the denominators, this one has a 2 in it and a 3 in it. This one has a pair of 2's and a 3. So they are almost identical denominators. They both have a 3 in them, they both have a 2 in them. The problem is this one has an extra 2. And so when we get common denominators, what we actually are doing is we are putting in that factor by multiplying who's ever short of it by a version of 1. I'll explain that in a second as soon as I write this down. What I've done is taken the 1 over 6, of course I've got it factored as this, and I've multiplied it by a 2 over 2. Okay? That will make my denominator a 12, but the reason it gives me the common denominator is now they both will have all the same 3 factors. If you have all the same factors, when you multiply them, you get the same number. And so by doing that, we get what we'd expect, 2 twelfths plus 5 twelfths. Now they have a common denominator. We got 2 out of 12, 5 out of 12. We have a total of 7 out of 12. And so that's how we add fractions. And it's important to understand this idea that we have to get exactly the same factors in our denominators, because when we're dealing with polynomial expressions, it's not going to be as easy as this 6 and this 12. We won't know just to, hey, take 1 6 times 2 over 2. Okay, so let's look at a few fraction problems involving polynomials. Let's see here. Okay, for our first problem, let's do this one. 3 over x plus 4 plus 2 over x minus 4. Alright, if I want to add these two together, they have to have the same denominator. And we can see right now in the bottom, this one has a factor of x plus 4, this one x minus 4. So, in order to get them to have the same denominators, they both have to have the same factors. So I'm going to take this one times x minus 4 over x minus 4. That way I'm just multiplying by 1. And I'll take this one times x plus 4 over x plus 4. And when I do that, multiply fractions just like normal. That's 3 times x minus 4 all over x minus 4, x plus 4, plus 2 times x plus 4 all over x minus 4, x plus 4. These fractions now have identical denominators, and I can add my numerators, and I can write my answer over that denominator, that common one. Now I wouldn't leave my answer like this, and I'm certainly trying not to do too many steps at one time, but now I have to clean up this numerator here. That's going to be 3x minus 12 plus 2x plus 8 all over that denominator again. And then I would collect my numerators like terms, so 5x minus 4 over the common denominator. And so that's it. We're just getting all the factors the same in both denominators, and that way we can add them just like we've always added fractions. Okay, let's try another one of these. Here's a good one. 5 over x squared plus 4x plus 4 plus 6 over x squared minus 4. Now I could, if I wanted to do it kind of by brute force, I could treat this as one factor and this is one factor and just multiply and times each other to get my common denominator. But it's much more elegant and a lot quicker if you factor your denominators first to see what they're made of. And now if we compare these two, this one has an x plus 2, x plus 2, x minus 2, x plus 2. So they both have this in common right now. The guy on the left is missing an x minus 2, so I'm going to put one of those into the denominator by multiplying by 1. And the one on the right hand side is missing another x plus 2, so I'm going to take it times 1 to put it in there. Again, a version of 1. And so now we can see when I multiply all three of these together, that would be the same polynomial as those three, and I'd have common denominators. So what I like to do then is say, alright, here's my answer. It's going to be that common denominator. All underneath, and we'll do a little distributing here as we write down the numerator. 5x minus 10. A little distributing here, 6x plus 12. Giving us a final result of 11x plus 2 all over x minus 2, x plus 2, x plus 2. And that is our final answer. Do one more with a subtraction problem in there. Let's do, this one looks a little tricky, x squared minus 2 over 3x squared minus x minus x squared minus 3 over 3x minus 1. Again, let's factor the denominators. So pull an x out, 3x minus 1. And I can't factor anything out on the right-hand fraction. If I compare these two denominators, they both have the 3x minus 1 in them. This one has an x. So I'm going to take this one times an x over x. And so I'm going to end up with this common denominator. Let's go ahead and write it right here. Ooh, I don't want to go too fast because this one's a minus sign. It'll throw us off a little bit. Okay. And so it's going to be x squared minus 2 minus, and the tricky part is this is a grouped binomial because it's in the numerator, so I have to think of it as minus the quantity x squared minus 3 times x. Okay, and that's going to do two things. That means I've got to distribute that negative sign, and then I'm also going to have to distribute that x. And so the simplest way to do this is to take that x and think of it as being right out in front. It's all going to be over this denominator that we created, x times 3x minus 1. And so it's going to be x squared minus 2, distribute that negative x now, minus x cubed plus 3x all over my denominator. And then finally collecting like terms. Looks like we've got a negative x cubed up there, an x squared, a 3x, and minus 2. I actually didn't have any like terms to combine. I just put them in standard order. And you're finished. So you take it times a version of 1 in order to get all the factors in everybody's denominator the same. Then you just add your numerators or subtract your numerators depending on what the case may be. Hope that helps.